Assalamu alaikum warahmatullahi wabarakatuh. Student, welcome to class 8. I hope all of you are fine. Today is our first online maths class. I am your maths teacher, Mrs. Farah Nasir. Today our topic is operations on sets. I am in chapter 1. You know all about the sets because in the previous classes you learn about the definition and the operations on set. Before starting the same topic, I want to tell you about the set theory. Set theory is a branch of mathematics that studies set. It is the creation of Georg Cantor, who was born in Russia on March 3, 1845, and he was a German mathematician. He published an article which marked the birth of a set theory. Georg Cantor died in Germany on January 6, 1980. In our daily life, we use many words about sets. In our like sofa set, tea set, water set. So according to this, a set is a collection of well-defined, distinct objects or symbols. The objects are called its member or elements. Like A is equal to A, B, C. We always represent the elements or member of the set with the small letters or small alphabet, and we represent the set with the capital letter like A, B, X, Y, Z, like this. And also you learn set of natural number, odd number, even numbers, whole numbers, integers in the previous classes 6th and 7th. In this chapter, we will learn about the subsets, type of the subsets, and then power of set. First of all, I told you the definition of subset. A part of larger group of related elements. For example, B is equal to 1, 2, 3, 4. A part of the larger group means the subsets are the sets which we take from the larger one. For example, B set is given to you 1, 2, 3, 4 and 1, 2, 1, 2, 3, 2, 3, 4. These are all the subset of the set B, and you see they are the smaller than the given set. This is the subset. Now we have two types of subsets. One is proper subset and the other is improper. Proper subset. If A and B are two sets, when we are defining the subset, we always comparison between two sets. Same here, proper subset. If A and B are two sets, then every element of set A is also the element of set B. But at least one element of set B is not an element of set A. Due to this definition, it means that B will be the larger and A is the smaller set. At least one element will be in B which is not present in set A. Now see the example. A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4. You see that there are 4 elements in set B and 3 elements in set A. So A is the smaller set and B is the larger one. Then we said that A is the proper subset of set B. You cannot say that B is a proper subset of set A because B is the larger set and A is the smaller one. Now we come to the improper subset. Now see, you see on your screen the definition of improper subsets. If A and B are two sets and set A is a subset of set B and B is also a subset of set A, it means A and B, they both are subset of each other. Then we said that A is an improper subset of B and B is an improper subset of A. This notation is used for the improper subset. Is it clear? Now we come to the power of set. Power of set, we represent it P of A. This is not the type of the subset. Actually, this is related with the set. A set consisting of all possible subsets of given set A is called power set of A and is denoted by P of A. A set consisting of all possible subsets. It means that this is also, there is a relation between the subset and the power set, but when we finding the subset of the given set, they are all the elements of the power set. So there is a relation between a power set and a subset. A set consisting of all possible subsets of given set A is called power set of A and is denoted by P of A. We read this P of A. For example, A is equal to AB. We have two elements, A and B. Now P of A, when we are finding the subset or we are writing the subset of the given set, we always start from the null set. The null set will be the first subset of the any given set. So null set, then the singleton set. You know which sets are singleton, in which only one element. You see on the screen A, B, they both are singleton because there is only one element. And then AB. Null, A, B and AB. There are four elements in a power set of A. We also have the formula. This is very simple, that how we can come to know that any set have how many possible subsets. For this we have the formula 2 raised to the power n. N represent the number of elements in the given set. If two numbers are given, we take n is equal to 2, then there will be 4 possible subsets. If there are 3, 2 raised to the power 3, we write there 8. It means that when you are finding the possible subset, they will be 8. And if you have null set means there is no element. So it means we take n is equal to 0 because there is no element in the null set. So instead of n, we put there 0 and 2 raised to the power 0 is equal to 1. So when we are finding the subset of the null set, it means only there will be one subset of a null set. From all these discussions, we conclude that every set is a subset of itself. Every set is a subset of itself. You see here, P of A, the last set is AB. And the given set is also AB. So every set is a subset of itself. And empty set is a proper subset of every non-empty set. I told you that when we are finding the subset, we always start from the null set. It means that null set is a proper subset of every non-empty set. Is it clear? Okay, now we come to our exercise 1.1 on page number 4. Question 1, write all subset of the following sets. So before the solution of this, I again repeating the definition of subset. A part of the larger group of related elements. For example, B is equal to 1, 2, 3, 4, 1, 2, 1, 2, 3, and 2, 3, 4. Now keep this definition in mind, and I'm showing you the solution of the question 1. The first part is null set. I told you many times that when we are finding the subset, the first subset will be the null set. And again, we apply the formula. We check that how many possible subsets of this question have. There is no element is there, so we put n is equal to 0. 2 raised to the power 0 is equal to 1 because this is empty set. So when we are writing the subset, the first subset and only the one subset, which is the null subset itself. Come to the second question. Second part of this, 1. Singleton set. Only one element is given. And now we see that how many possible subset of this set have. Again, you apply the formula 2 raised to the power n. Because there is only one element, 1, so instead of n, we put there 1. 2 raised to the power 1 is equal to 2. It means that singleton set have two possible subset. Singleton set have two possible subset. Now see the solution. Subset. First subset is null and the other is singleton. The set itself, that I told you, that every set is a proper subset of every non-empty set. Again, third part, there are two elements, A and B. Apply the formula 2 raised to the power n. N is 2. 2 raised to the power 2 means 2 multiplied by 2. 2 times 2 is 4. It means this set have 4 possible subset. 4 possible subset. One is null, then A, then B, and at the end AB. 4 possible subsets, null, then 2 singleton sets, and then at the last the subset of the set AB itself. Now you see in the question, we conclude that if there is only null set, no element is in the set, then we have only one subset of it. If we have singleton set, then the possible subsets will be 2, the null and the set itself. And when we have 3 elements, then we have 4 possible subsets, null, 2 singleton, and then at the end, the set itself. On the same pattern, if we have 3 elements, it means that we take n raised to the power 3, 2 raised to the power 3, then it will be 8. Now we come to the question 2. Write all proper subsets of the following set. Before doing this, I again recall the definition of the proper subset. If A and B are two sets, and every element of set A is also the element of set B, but at least one element of set B is not an element of set A. See in the example directly, B is 1, 2, 3, 4. So 4 is the at least element which are present in B but not in A. So it means A is a proper subset of set B. A will be the smaller one and B will be the larger. Come to the exercise. You see on your screen question number 2. Write all proper subset of the following. Part 1, A. Singleton set is given. Proper subset, null. Second is 0, 1. 2 elements are there. Proper subset. First subset will null, then 0, then 1. There are 3 proper subset of the given set. Then in the third part, 1, 2, 3. Then again, I told you we will always start the subset from the null set. First null, then singleton 1, then singleton 2, then singleton 3, then the pair of 2 elements of the set 1, 2, then we make the pair with 1, 3, and then 2, 3. In the sets, you cannot write 2, 3 as 3, 2. Order is compulsory in the sets. We cannot change the order. Because in the question 1, 2, 3, order is first element is 1, then 2, and then 3. We cannot write the order that 1, 2, we cannot write it 2, 1. So that's why when we are finding the subset, we are going in the order 1, 2, 1, 3. Then 2, 3. Is it clear to you? Okay. Now we come to the third question, the last question of the exercise. Write the power set of the following sets. Before finding the answer, we go back to the definition and we see how we find the power set of the given sets. I told you that power set is not the type of the subset. A set consisting of all possible subset of given set A is called power set of A. It means that we find all the possible subset and we enclose the subset within the curly bracket. Then the set is called the power set of A or P of A. Is it clear? And the same formula, because the subsets are the element of P of A, so that's why the same formula which we use in question 1 when we are finding the subset, we use the same formula for the power set of A, 2 raised to the power n. Here's question number 3, part number 1. -1 and 1. There are two elements. I told you for power offset, we again use the same formula which used in the question 1, 2 raised to the power n. There are two elements, it means we take n is equal to 2. 2 raised to the power 2 is equal to 4. It means when we are finding power of A, there will be 4 elements in power set of A. We starting from the null set. First is null, then singleton -1, then singleton 1, and at the end -1 and 1. We check again, either there are 4 elements or not. 1, 2, 3, and 4. And you see that I enclose all these subset within the curly brackets. Yes? Because we are finding the power set of A and we always use a curly bracket for the sets. So that's why the elements also have the curly brackets, and the P of A, we enclose all these subset within the curly brackets. Is it clear? This point is clear to you? Yes, the last is A, B, C. Now see, there are 3 elements. N is 3. According to the formula 2 raised to the power n, we put n is equal to 3. 2 raised to the power 3, 2 multiplied by 2 multiplied by 2, 8. It means the power set have 8 elements. We start, first set will be the null, then singleton A, singleton B, singleton C, then the turn of 2 elements A, B, A, C, B, C. Now at the end we take all the elements at a time A, B, C. Again we check either there are 8 elements or not. First is null 1, 2, we check how many elements are there. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 elements in P of A. And again I enclose all these subsets in the curly brackets. I think this exercise is too much easy because you have already know about the sets in the previous classes. We have only 3 new things in this lesson: subsets, proper subset, improper subset. These are 2 types of the subset, and then power set of A or power set of any set. And we find the formula to find the elements of power set of A or the all possible subset of the given set, which is 2 raised to the power n. Yes, student? Again, I recall all my definition. We done the definition of set. Set is a collection of well-defined distinct objects or symbols. These objects are called the elements. You have sets. A set is collection of well-defined distinct objects or symbols. The objects are called its member or elements, A, B, C, and we always represent the elements of the set with small alphabet and the set with the capital letter. Then we read about subsets. Subsets are part of the larger group of related elements. For example, B is 1, 2, 3, 4, and we write 3 subsets there: 1, 2, 1, 2, 3, and 2, 3, 4. Because a larger part is 1, 2, 3, 4, and they are the sub part of the set B. Then we have two types of the subset. First one was proper subset. If A and B are two sets and every element of set A is also the element of set B, but at least one element of set B is not an element of set A. See the example, B is 1, 2, 3, 4 and A is 1, 2, 3. We see that B is a larger, again A is a smaller one. So we said that A is a proper subset of set B. Then we come to the improper subset when A and B are two sets and A is a subset of B and B is also the subset of A. Then both the sets are subset of each other. Then we said that A is an improper subset of B and B is an improper subset of set A. The difference between the proper and improper is that in improper, both A and B can be the subset of each other, but in the proper subset, only one set will be the proper subset of the other. And at the end, we did power set of A. Power set, when we find all the possible subset of any set and we enclose it in the curly brackets, then that new set is called the power set of that set. And we represent it P of A or P of B or P of C. To finding the element of the power set of A, we use a formula 2 raised to the power n, and n is that number, the elements of the set, any set. If two elements are given, we replace n with 2. If no element is given, we replace n with 0. If 4 elements is given, we replace n with 4. And the same formula we use to finding the subsets of the set. I hope you learn this exercise and all these definitions very well. Our next topic will be operations on set. We will do, inshallah, union, intersections, and about the properties of union and intersection. Allah Hafiz.